How interesting. All right, Guido, do you have one more you want to share with us, or you got mine?
Well, yeah, you gave me some homework. I didn't really do it, but there's like, and of course this has to do with parsing. And so this may be a fairly esoteric library, but if you're writing a program that sort of does some manipulation of your code, and maybe it converts 4-space indents to 2-space indents or 3-space indents or whatever, or maybe you're writing something like black, which is the sort of the Python code reformatting tool, but you don't like the way black handles certain things. Or maybe you're sort of writing some other thing that does analysis of source code. Maybe you're writing a linter. There are a couple of tools that you can use, and it turns out that one of them is in the standard library. There's something called lib223, which is a little hard to pronounce. It has the digit 2 and then the word TO and then the digit 3 in the name.
That is tricky.
That is something I wrote probably over 15 years ago, or at least the core of it, which is yet another LL1 parser, but this one's written in Python rather than in C like the original one. But actually, Black ended up using lib223, except I think Lukács had one issue that he couldn't figure out how to do with Black. And so he ended up vendoring a copy of lib223 and then butchering it a little bit. Which is how these things happen. I mean, if you look at what pip vendors, that's pretty scary, but there are good reasons for that too. So, but if you're writing your own, you should probably not use lib223, and not just because it's going to go out of style once the peg parser arrives. There are much better tools, and the one that I discovered a few months ago is actually written by some folks at Facebook mostly. It's called LibCST. And they have unique capitalization. It's a capital L lib and then lowercase ib, and then CST is all uppercase. And so it's a library for manipulating concrete syntax trees. And like lib223, it actually shares some code with lib223. I think the underneath is a parsing library called Parso, which itself is a butchered version of lib223. At least that's how it started. So all these things these tools are things that can parse Python code, but they produce a syntax tree that is the opposite of an abstract syntax tree. It's a very concrete syntax tree, and that means that every space, every comment, every bit of indentation is preserved, or at least can be recovered from the information in that syntax tree. And oppose that with the typical abstract syntax tree, which in the end doesn't even remember where the parentheses are.
Right. It just takes it up. Well, here's some conditional statement. Here's the two things we're testing.
Yeah.
So this sounds much more useful if you want to do like a code analysis type of thing to say, this thing you're doing here, you should do it in this other way or transform it over, but kind of preserve things like comments and style.
Yeah. And so LibCST has a really sort of solid underlying model, and they thought a lot about various transformations they want to apply, because the typical way these tools work, and lib223 itself started out that way as well, is you read your source code using this customized parser. It gives you a concrete syntax tree. Then in that syntax tree, you're actually going to make changes. You're going to systematically rename a parameter, or move things around or insert. In the 223 world, of course, it's used to turn things like iter items into items and iter keys into keys, and you can make that kind of changes. And so LibCST also supports that, but it sort of has a slightly better API because 15 years ago when I started lib223, I didn't realize what an important tool it was going to be. And some of the I think the way the white space is attached to nodes is exactly backwards from the way that is the most convenient to think about it and work with it.
Right. Cool. Well, this sounds like it'll be really helpful for people building tools like Black or looking at code analysis and stuff.
Mm-hmm. Right.
One of the Lukesh had I think it was the 2019 talk, PyCon talk, where he described how Black uses both concrete syntax trees and the abstract syntax tree. It's a pretty fascinating talk for a very low level depth into these concepts. But it wasn't until I watched that talk that I realized that Black compares the before and after abstract syntax tree to make sure that your code is guaranteed to run the same, so you don't really have to test for that. He's already testing for it, so that's pretty interesting.
Yeah, that's cool.
That is a very neat feature, and it's actually an important trick in general for people who are doing transformations to have some abstract way of double checking that your transformation left things in a decent state.
Yeah, it's cool.
Yeah, very cool. All right, well, thanks for LibCST, Guido. That's a great one. Thank you for watching this segment of the Python Bytes podcast. This video was made during the recording of the full episode. Visit pythonbytes.fm and get the whole story. Subscribe to the podcast and get the entire episode delivered to your phone. Please support our work by taking one of the courses at pythonbytes.fm/courses or learning PyTest with Brian's book at pythonbytes.fm/PyTest. Finally, visit our sponsor shown on the screen here. Visit the link on the screen and get the special offer for Python Bytes and YouTube listeners. Thanks, and have a great rest of your day.